Welcome, SciFest participants. I'm Dr. Ryan Hayes. I'm in the chemistry department at Andrews University, and I'm excited to lead you through this experiment that you're going to do at home or at school in your group there for the chemistry challenge. We are going to learn how chemists take things that are invisible and cannot be seen and make them visible and analyze them and tell how much is there. We don't just blow up things. We help people to see the unseen. So we're going to learn how diseases are detected that go along with our COVID-19 theme. And this is a big role that that chemists play, not only in this pandemic that's going on, but across the board. There are many companies that hire chemists to do chemical analysis. They need to know how much of whatever their product is. Maybe it's how much protein they put in, nutritional analysis. This is all done by chemists. There are many chemists developing medical related technologies to detect certain proteins or enzymes or certain disease states and things that are going on inside the body. Certainly to help detect in fast, quick, accurate ways of how much is there, especially when it comes to COVID and how much virus is there. One of the ways that scientists do that, and specifically chemists, is we try to figure out how can we take something that's invisible and make it colorful? How can we make it absorb or emit light in the visible wavelengths? If we can, then we can use a special device called a spectrometer to figure out what color it is and how much is there. So your goal in this task is to build your own spectrometer. And with today's technology, it's not that hard to do. So you're going to build your own working one using your phone, flashlight, some other materials that I'll tell in the next slide. So you're going to get points for analyzing and making a known graph based on the response that your phone will give to your different solutions that you're going to make. I'll explain. So you're going to need some materials. What are you going to need? Well, you're going to need a phone, smartphone. You're going to need a flashlight because you need light to go through your solutions that you're going to make. Then you need a cup, glass, or clear plastic of some sort that the light can go through. Then you're going to need some food coloring and make known solutions. Like I'll make a solution with 1 drop in it, then a second solution with 2 drops of food coloring, and a third one with 3, or some variation of that. You come up with it. Once you have, so you got your food coloring, your cups, flashlight, phone, what else you got? I'm looking. Oh, you need a special app from Google called Science Journal app. It's free. You need to download it. I'll say a few things in a moment about that. What's your method? The method is going to, for you to figure out how to set up your phone, flashlight, your solutions, and hold them in such a way that you can get good, consistent readings of how much light is there when the flashlight is shining light through the sample. How can you be consistent? Keep track of all the things that you're having to control, like how much light is going through, the distance, and how you arranged everything. So think about the variables that you have to control. Then your teacher needs to make an unknown, or some parent make up a solution that you don't know about, and maybe they can split a drop or something and figure out how to put like 1.5 or 2.5 or 3.5 drops and see if you can figure it out. So how are you going to do that? Well, your app is going to be able to give you an intensity reading with each one of the standards. Then you're going to make a plot in Google Sheets. That's free. Or if you got Microsoft Excel, you can do that there. And you're going to do XY scatter plot. And I have a link to a video in Learning Hub that you'll be able to make, and it should be on these slides as well, that will show you how to make an XY scatter plot that'll show a trend line. And that trend line will have an equation that's in the linear format, y equals mx plus b. And that will be used to analyze your unknown. And then there will be this R squared thing that you're going to have to report. So make sure you get those things. The Science Journal app from Google is pretty neat. It's got a lot of ways that this app can get into your phone's sensors and make different readings. There's magnetism, light intensity, orientation of things. It's great, it's cool. If you haven't got it, get it on your phone. You're on your way to becoming a scientist. So get that app, download it. There's other apps, but this one's good. It's free. I've used it. It worked well. Feel free to use another one if you'd like. Let me know about it. All right. So the teacher or some parent or someone else will make an unknown solution using hopefully the same concentration that you were doing, concentration units like drops. But if you found another way to make concentration units, that's fine. You're going to make it and you're going to analyze it. Hopefully you analyze it using all the conditions that you have set up when you did the standards. Okay? And then you should be able to use that trend line linear equation that you got from Google Sheets to analyze it. The intensity of light going through your unknown should be your Y variable, and then you got to use some algebra to solve for the X variable. All of this is called absorbance spectroscopy. See, the light is being absorbed by the colored solution, and your phone is the detector picking it up. Now we have way more expensive pieces of equipment here because it kind of holds all the variables together for us so that we can have very consistent, quick readings, and we can actually tell what wavelengths of light that are there, and our detectors are probably a little bit more sensitive. But you've built a spectrometer. That's great. There is a law that if you go look it up on the internet that relates a lot of the variables that scientists use when they're doing absorbance spectroscopy. Variables that are related are absorbance, concentration, path length, and this thing called molar absorptivity. Oh, I wish I had time to explain it, but it'll be built into the equation. You won't have to worry about it too much. All right, once you're done, I'm going to have a Google form that you can link to, and you can upload the data, and also like a picture or a short video of your experimental setup. Let's see your creativity. How did you do it? You probably saw some pictures of how I made my own and the slides that were here in this video. So there's a list of things. I need to know your equation. What was that R squared value that you got? And then your teacher can come up with a score from 1 to 5 on how you did in predicting the unknown concentration. Then list out all the variables that you had to control in order to make this experiment work. What is the name of that absorbance law that I just mentioned? You can go look it up. And then I want to see your setup. Then I'll use that to come up with a grade to see how well you did. If you have any particular questions, you can contact me directly by email or you can call. Yeah, that's my personal number, so don't spam me too much with text, but I'm happy to try to talk with you guys if you have some questions. All right, that's it for me. Now it's up to you guys. Go build that spectrometer and do some analysis of those knowns and unknowns. You got this.